Viewers, let us look at a recap of vectors today, and this is specifically for seniors 3 and 4, and we want to begin our lesson by talking about a translation vector. To define properly our vector, if we have what we call the Cartesian plane, y-axis, x-axis, and this is the origin. If a point A shifts a point A prime, it means it has moved a certain step or some steps along the x-axis. That's along the x-axis. Then finally some spaces along the y-axis, and this is a shift along the x-axis, a shift along the y-axis, and eventually reach point A prime, and we can represent that one with a single letter A. Therefore A prime can be given as a single letter A. Now, as we define that a vector has both magnitude and direction. It means the magnitude of A prime as a vector can be given as length of A, and the direction, you can see clearly that it moves from A to A prime in that direction. And similarly, if a point B, if it is here, moves to B prime along the xy plane, it means you can see that there has been a displacement from one point to another, and that one is a vector represented by B prime, and this one can be a single vector B, and therefore this one is also a translation vector as long as there is a move in a specified direction or in one direction. So a vector is always described as a column form. Say if we are given coordinates, say P -1, 4, then P can have OP, which is -1, 4, as a column vector, and OP is a position vector. Now, what do we call position vector, or how do we get the position vector? Similarly, if this is x-axis and y-axis, this is the origin, and you have one, calculate 1, 2, 3, 4, -1, then 1, 2, 3, 4. Point P is -1, 4, so this is point P, meaning that OP, it is a displacement of point P away from the origin, and therefore we can have OP from here to here. That is the position vector of P given as OP, and if we represent that one in vector form, then OP must be -1, 4 in column form. In general, if a point say P AB shifts or is displaced to another point P prime CD, then P prime as a vector is given as C minus A D minus B. So we can have a vector if you have point, say A, given as 3, 5, B, 6, 0, then the question may be find A, B vector. Therefore, to get the position vector of AB or vector AB, you get B or B, which is the position vector of B, minus OA, which is the position vector of A. And OB will be 6, 0, minus 3, 5. And you subtract as usual, you get 6 minus 3, 3, 0 minus 5, negative 5. That is the position vector of AB. Now, if we talk of addition and subtraction of vectors, addition and subtraction of vectors, let's consider a triangle OAB, such that OA is given as a single letter, say A, then AB is given by a single letter, say B, and this is OB. From the diagram, we shall say that if we have OA, add AB, this will give us OB. And therefore, we shall be able to see that OA as vector A, represented as vector A, AB vector B, this will give us OB. Similarly, you can have to illustrate vector addition using a parallelogram. Say A, B, C, D, whereby we have here A, B, C, D, where AD is parallel to BC, then AB is parallel to C. AB is parallel to DC, meaning that AD is parallel to BC. So if they are parallel, then they are equal. AB vector is parallel to DC, and therefore if AB is equal to DC, then AB plus DC should be equal to 0, because AB, in other words, AB plus negative DC, the reverse of DC, should be equal to 0 if this one is brought to the left. And that one means that we shall have a 0 vector. AB plus minus DC is equal to 0. In other words, when you look at the diagram and look at AB, then DC, then the same direction. But if you now go to CD, it means AB and CD are in opposite directions, and CD is the one we call negative DC. CD is negative DC. And in general, we shall be able to say that if you have a letter, say K, and is positive, if K is positive, if K is a positive number, such that K times a vector, say AB, it means it is a let k, which is a number, multiplied by a vector. And it means it is k times AB. If AB is represented by A, then KAB can be equal to K times vector A. And this one brings us to the length of a vector. Length of a vector. Now, we say that a vector is represented by direction and magnitude or length. So we can talk of length, magnitude, modulus. All these, you know, they mean the same thing. You can ask you length, they can ask you magnitude, or modulus or distance of vector. And here we shall use Pythagoras Theorem. Therefore, if we have a vector, say A as xy, the length of A, we can write A with two double lines, and this one is the square of x plus the square of y, or under root. Take note that they can give you a vector B, which is negative x, y. So the length of B, be careful, should be negative x in brackets squared plus y squared, and this one will be under root sign. Guys, that one can now lead us to the midpoint of a vector. We have looked at length of a vector, position vector. Now let's look at midpoint. Midpoint of a vector. If we have two vectors, say P and Q, if M is another point, let's consider position vectors OP and OQ. If M is a point in the middle or midway between P and Q, then we shall see that if this is P, this is Q, this is M midway, and it will mean that PM as a vector is equal to MQ as a vector, and therefore PM plus MQ gives us PQ. Since we say PM and MQ are equal, then we can have PM, then plus PM, since PM and MQ are the same, should give us PQ. Therefore, twice of PM should be equal to PQ, meaning that PM is equal to a half of PQ. So PM is a half of PQ, and therefore it should show that M is a midpoint of 2 points P and Q. And in general, we shall be able to say that this method will help us find the position vector and the coordinates of a point which divides a given line in a stated ratio. For instance, we can have P 6, 8, then Q, that is a vector, Q as 1, 2. Then if N is half of PQ, find coordinates of N, meaning that N is a midpoint of PQ, and therefore we shall look for PQ. And he said, don't confuse vectors with matrices. When they say PQ in vectors, that is OQ minus OP. OQ, that is 1, 2. minus OP 68, which gives negative 5, negative 6. N, can say ON as a vector, should be equal to half of negative 5, negative 6, meaning that negative 5 divided by 2 is negative 2.5. Then negative 6 divided by 2, that's negative 3, meaning that this is the position vector of point N. Therefore, the coordinates of N will be negative 2.5, then negative 3. So that's how I write from position vector to coordinate. Now we have to look at parallel lines and collinear points. If we have 2 points, say A and B, it means if AB is a vector and KAB is another vector but a multiple of K. Now, if AB has a length K, AB, it will mean that AB is the same as K, AB, where K is a scalar. E.g., we can have points A given as coordinates, given as a vector 8, 6, B as 6, negative 4.5. Then they ask you to find the length of A. So length of A will be 8 square plus 6 square, which will be 36 plus 64. This is 6 square, 8 squared, which gives us root of 100, which is 10 units. Length of B the same way, and now AB, use capital letters, AB will be B minus A. And we shall be able to see that B is 6, negative 4.5, minus A, 8, 6, which will be negative 2, negative 10.5. That is AB. So find the length of AB, and the length of AB, AB is negative 2 squared plus negative 10.5 squared, and this will be under root if we are looking for the length of AB. So this the length of AB now becomes 4 plus 110.25 or under root sign, which becomes literally the square root of 114.25, and using a calculator it will give you 10.6888 units. Consider our discussion with parallel lines and collinear points, and if you have the xy plane, xy, and say you have a line PQ and another line which is PR. P prime R. PQ and PR, P prime R are parallel because they don't share a common point and therefore they will never meet. So if lines are parallel, it will mean that PQ, if we use vectors, will be equal to a constant, say K, then P prime R, whereby K is the one that shows their connectivity as parallel lines. But if you have another point, say M on PQ, such that PM becomes parallel to MQ, then it means PM and MQ are parallel and they are collinear because they share a common point M. So PM and MQ are parallel, but at the same time they are collinear, or they lie on the same line because they share a common point M. Now, want to use a parallelogram or PQR with coordinates, that is O, P, Q, R. O is the origin, can have 0, 0. Then we also have point P as 5, 3. Then point Q as 7, 2. Then point R as 2, negative 1. So we can say that OP is P minus O, which is 5, 3. Then RQ, as we say that if you have RQ in vectors, it is Q minus R. So it is OQ 7, 2 minus 2, negative 1, and this will be 5, 3. Now you can say that RQ is equal to OP. They are equal, and on our diagram they are parallel. Therefore, OP is equal to RQ, and therefore is parallel to RQ. So if lines are equal and parallel, then it means the modulus of one line is equal to the modulus of the other line. And we move to OR and PQ. We also see whether they are parallel. So OR is given as R2, negative 1, and PQ is Q minus P, which is 2, 7 minus 5, then 2 minus 3, negative 1. You can see clearly that OR is equal to PQ, and on our parallelogram they are parallel. Now, when we talk of collinear points, these are points which lie on the same line, and if we have A, B, and C which lie on the same line, then we shall say that AB is connected to BC by a constant, say K. We call it a parameter of BC which connects them. But since they share a common point B, it means they are collinear. They can ask a question that shows that point A with coordinates 5, 3, B with coordinates 2, 7, and C with coordinates negative 4, then 15, that they are collinear. It will mean that as part of the solutions, you can have AB, which is B minus A. Don't confuse vectors with matrices, please. AB, it is B 2, 7 minus 5, 3, which is negative 3, then 4. Now, BC, it is C minus B 2, 7, which is now negative 6, then 8. Now, you'll be able to see that AB and BC have something in common. AB is vector negative 3, 4. BC negative 6, 8, which is, when you look at 3 and negative 6, they have a multiple of 2, similar to 4 and 8. Therefore, this is 2 into negative 3, then 4. Such that BC vector equals twice of AB. So when you connect back, you will see that the K I was talking about is now 2. So AB can as well be written as a half of BC if you divide by 2 both sides, meaning that AB is parallel to BC because AB is a scalar multiple of BC, where our scalar K is a half. But since they share a common point B, it implies that A, B, and C are collinear. So when you conclude, you say that AB is parallel to BC because AB is a scalar multiple of BC. But since they share a common point B, it means these 2 points, these 3 points A, B, and C are collinear. Now, let us consider a triangle O, Z, Y, such that there is an altitude that is dropped from Y to another point X, such that from O to X is small letter x, then from O to Y is small letter y. So OX is vector x, OY is vector y. Now, if OZ vector is 3OX, x plus 2OY plus ZY in terms of x and y. So you have a diagram, and you know that from here to here is given represented by letter x, from here to here by letter y. But they want us to express 2OY plus ZY in terms of small x and y. So we shall use our vectors still, and we follow direction according our diagram, and our solution will be 2OY plus ZY will be equal to, we know that OY is given as vector y, and therefore we shall have 2y. So please don't forget to put the sign for a vector, followed by ZY. ZY. But ZY we can get it from ZO followed by OY. So we can have ZY. But ZY as a vector, ZY, if you want to move from Z up to Y, then you can take direction ZO, then OY. So we can have ZO followed by OY. But we have got OZ. Therefore, ZO is a reverse of OZ. Therefore, ZO is a reverse which will be a negative 3OX. But OX is given as vector X. Now, followed by OY, which is vector Y. This is now it means that 2OY plus ZY will be equal to 2Y followed by O plus ZY, which is Y minus 3X. Don't forget vector symbols. This will give us 3Y minus 3x vectors, but 3 is common, which you can factorize out, shall have y minus x. So this is how we can express a given expression in terms of vectors x and y.